Today's topic is protecting sensitive data in the Oracle E-Business Suite. And so we're going to talk about a process, what sensitive data is, what the process you have to go through to protect it, and then actually go through a number of different solutions. So before we jump into the webinar, give you a brief background about Integrity for those of you not familiar with us. We specialize in Oracle security, particularly Oracle E-Business Suite security. And we've got a line of products, one being App Sentry, which actually will scan your Oracle E-Business Suite environment and find security vulnerabilities. And App Defend, if you're running on the internet, it will actually help protect against critical patch update vulnerabilities and things like that. And then the other side of our business is actually consulting and services, and we actually perform on-site security assessments and security design services. So a lot of this presentation today is based off of what we've done for different clients in protecting their sensitive data and how to set up encryption, database access controls, things like that. One of the questions we do get quite often is why do you know so much about Oracle E-Business Suite? Well, we spend a lot of work internally actually researching, finding security bugs, finding better ways to do things. So we've actually found more than 80 security vulnerabilities in the Oracle products. And here's just kind of a little bit of a brief sample of them. We've actually got, I think, about 20 more open with Oracle right now. So there'll be a lot more critical patch updates coming, but that's not the topic today. So we'll kind of get started with that. So today we're going to talk about sensitive data in your Oracle E-Business Suite environment. And we're going to focus in on the Oracle E-Business Suite because there is a lot of limitations and caveats about how to protect sensitive data. You just can't do everything you do with a normal Oracle database. So some of the products work, some of the products don't. So we'll give you an overview first, talking about sensitive data. What is it? What's the process you need to protect it? And then actually go into some of the solutions, including encryption, database access controls, and auditing. And we'll leave the last little bit open for questions and answers. So if you do have a question, please feel free to enter it into the question feature as part of the GoToWebinar. So let's first talk about sensitive data and kind of give you an overview of what we're kind of coming from and the topic in general. So really the why. Why do you have to protect sensitive data? Well, you don't want to be a front page headline. You don't want to be one of those companies that basically lost all their social security numbers or credit card numbers. And so basically there's a couple of regulations that require you to do that. If you have credit cards in your environment, you have to adhere to the Payment Card Industry Data Security Standard, PCI-DSS. PCI-DSS says specifically you have to encrypt credit card numbers. So we'll talk about that requirement in a little bit more detail as we go through this. A number of states, I think the count is something like 33 or 34 now, have privacy regulations. And most of those regulations are pretty straightforward. And what they say is if you have some sort of account number, either a national identifier like social security number or bank account number, and you lose that data, you basically have to disclose to everyone who lives in that state. California's SB 1386 is probably one of the more, was the first. Massachusetts has a pretty rigid law also, but a number of states have them. And then also Sarbanes-Oxley fits into this a little bit because some of the auditors do require that as part of their SOX audits, a lot of people's internal controls. So that's kind of the background. I won't go into much more why you need to do this. I think everybody on the call is concerned about sensitive data. But to kind of highlight some of the regulations that really drive this area. So let's talk about what is sensitive data in your Oracle E-Business Suite environment. This is very specific to your organization. What you deem sensitive data, personally identifiable information, private information, really depends on the organization's internal standards, data security policies, and actually what you have in the Oracle E-Business Suite. Throughout this presentation today, we'll actually concentrate just on a few items, mostly credit card numbers and social security numbers, because those are very representative. When we talk to most customers, they're really concerned about credit card numbers, social security numbers, bank account numbers, things like driver's license numbers, numbers and account information that they have. Some organizations take this to an extreme that they also talk about salary information and things like that. The more data elements you have, the tougher it is. One of the more complicated areas is we've actually worked recently with a medical device manufacturer. Well, they have customers that actually order directly from them. And since that's medical information, that they're using a specific device, all of their AR system is actually considered private information. It actually has to go through with HIPAA. And so it really depends on your organization, what you deem critical. But throughout this presentation, we'll kind of highlight sensitive data being credit card numbers, social security numbers, but we mean whatever your organization is looking at in terms of sensitive data. So that's kind of the different data elements. So where is sensitive data in the Oracle E-Business Suite? This is one of the more complicated issues because it's scattered throughout the environment. It's in the database, it's in log files and things like that. So in the standard Oracle E-Business Suite tables, there's credit card data in a number of different tables. If you're running the Oracle credit card encryption feature, it's actually hopefully in one table, IBY security segments. If you're not, it's actually in 6 or 7 tables depending on what modules you're running and things like that. Social security number can be in a number of different tables. And when we talk about social security numbers, we may be talking about your employees' social security numbers. We also might be talking about tax IDs. If in your AP system, you might actually have social security numbers because you may have some suppliers who are self-employed. Therefore, they use their social security number as their tax ID. So throughout your AP system, maybe scattered social security numbers, especially for 1099 members and things like that. Bank account numbers are also throughout the system because you may be paying employees, you may be doing it as part of AP, you may have it as your enterprise bank account numbers. Then you might also have some protected health information. That might be in HR. If you're dealing with any kind of medical equipment, you may have it in your accounts receivable system and order management. So the key is even in the standard tables, it's scattered to the wind. There's no definitive list, and the list I have here is probably a partial list. This may be half the tables. We could probably pick off a lot more that would actually have some form of sensitive data, especially now if you try to expand that beyond bank account numbers and social security numbers and credit card numbers. If you talk salary information, that's in dozens and dozens of tables. A date of birth maybe in 3 or 4 tables. So it really depends on what you need to protect in your organization. But the key is it's not easy to find. There's no standard list provided by Oracle. These lists here are provided by our projects that we go through and we scan for sensitive data, and we actually compile these lists of standard Oracle E-Business Suite tables. Well, if you've got standard Oracle E-Business Suite tables, where else might data be? Well, you have a lot of custom tables. So a lot of the customizations, you've created custom schemas with custom tables. And there's lots of interfaces, lots of custom programs running against those. Those might have sensitive data, particularly if you're running credit cards. A lot of e-commerce systems accept the credit card, then pass it to Oracle E-Business Suite through an interface. Well, that probably ends up in a custom table before it's getting put into order management. One we always find interesting is what we call maintenance tables. The classic maintenance table story goes, well, the business analyst found a problem, maybe in, let's say, HR. They contacted Oracle, and Oracle said, oh, run this SQL script against the PER, all people F table, which is the key table in HR that has national identifier or social security numbers. And so, of course, what does any DBA do is they do a create table as select to create a backup of the table before they run the direct SQL update. And then they basically do that. Then they go back to the business analyst and say, okay, I ran your SQL script. Let me know if it worked. Well, they forget that they actually created that backup table. And that backup table now sits out there. So even if you have a very good, stringent scrambling, data encryption, well, you've just kind of blown that all out of the water because now you've got your social security numbers in a separate backup table. Another area is interface tables. So interface tables are really transient. You really should be just loading, let's say, orders with credit card numbers on them into the interface table. That interface table gets processed and deletes out the records. Well, 2 things. One is they're in there temporarily. So if there is a gap between when that concurrent manager program runs to empty the table and when they get loaded in, it can be an hour, it can be a day. Some organizations just load maybe once a week in some interface tables. So that data is sitting out there. Do you have to be encrypting that data? Do you have to be protecting that data? Then also some interfaces run and error out. So we actually find a lot of interface tables that have maybe 10, 20, 100 records in them because those were errors. And someone should have gone in and cleaned those out, but that didn't happen. Another table and kind of area where we do find sensitive data sometimes is flux fields. And this one is actually exceptionally hard to find. Because you may just pick off a flex field and say, well, we're going to enter a social security number there for some reason or credit card number. We don't find that too often that people did it recently. What happens is that happened maybe 10 years ago and they added that flex field in and everyone kind of forgot about it. The end users know that they have to enter into that field, but they don't realize it's a flex field. And then that's for the database. Now for the operating system, you actually have interface files. You may have log files. Log files are particularly important because like iPayment, which processes the credit cards, can actually write out most of the credit card information into a debug file. We actually had one client that basically they had full debugging turned on in iPayment in their production environment, and they happened to also let that log file location be allowed under anonymous FTP. So they actually had all their credit card information processing for, I think it was about 5 years in a log file that then anyone could use FTP to download from their application server. So you just don't know where sensitive data is, and you actually have to do a little bit of work to find it. Actually, I'll show you some real life client data. So I actually have anonymized this data, so changed all the names and most of the table names to different names. But basically, this is an example of a sensitive data search that Integrity performed for a client. And this is an Oracle Business Suite production environment. And if you look at these couple tables here and columns in blue, these are only the standard tables that contain sensitive data. So these are standard pay external accounts, PRL people F. Those are basically tables everyone here knows very well. The rest of the tables here, and actually in this spreadsheet, was a full inventory of where they have so mostly Social Security numbers, some bank account numbers, and a few credit card numbers. But there's 168 locations, and in their environment, they only had 3 standard tables. So now we're talking about 165 custom tables that they had that had some form of sensitive data. And then it's a little bit hard. A lot of people say, oh, yeah, we'll just search for the column national identifier, and they'll pick off every column we have, right? Well, in this case, in pay external accounts, they actually have bank account numbers in segment 4. That's a very standard location for it. In segment 3, well, they've got some credit card numbers there. How about attribute 15 in this custom table that basically, I'm not even sure what that table is, but it had bank account numbers in it. FEIN had some Social Security numbers. We go up a little bit higher and we actually see 1099 numbers, which are Social Security numbers, but basically they're self-employed people that use their Social Security numbers, their tax ID and this organization generated 1099s for those people. So you can see it's not easy just to do a simple query and say, okay, we'll search for SSN column names or a national identifier. The data can be in just about any column, and unless you have a search tool that can actually go through and go table by table, column by column, and actually sample data to actually look for what looks like either Social Security numbers, credit card numbers, it's very hard to find. And this is one client example. And so we also have a couple here. Remember I talked about that maintenance table? So this table here was basically a backup. It fortunately only had one Social Security number, but that's a backup of the PRL people F, and they actually had 3 cases of that. Fortunately, they were only subsets, but that's actually pretty common. We see that a lot. Here's another one. So in this one database, they had 4 backups of the PRL people F table with about, let's say, 8,000 Social Security numbers in it. So after you've done kind of a data scan, then you need to check that the data is actually good. And in a lot of cases, when you actually look at the data, it may not be a lot of records in a table. So after we actually do the search to look for credit card numbers, Social Security numbers, we actually do a data quality analysis to say, okay, is that legitimate data in that entire table? For those of you familiar with credit card numbers, it's actually fairly easy to do because they follow a very standard pattern. So their Visa numbers are always 16 characters. They start with a 4, and the last digit is called the loon check digit. So it's actually a validation checksum of the previous 15 digits. So you can actually validate if it's good or bad. So in this case, we did data analysis, and this was on the OE order headers all table. So this is order management, the credit card number column. And so in this particular environment, they had 10 million orders about in their Oracle order management system. Well, they typically don't do credit card numbers, but they do it in some cases for kind of repairs, small items that people order through one website. So this table had 9.2 million rows, but only 82,000 credit card numbers. And this is actually validated. So we actually went through and said, okay, here's the actual credit card numbers that matched the certain patterns, matched the check digit, and were valid numbers. So it's sometimes very hard to find. So you might just do a quick query on your order headers all table and actually say, oh yeah, I didn't see any credit card numbers there, until you actually get down and look at the 1% or less than 1% of the rows that would actually have valid credit card numbers. It could be hard to find. So you have to make sure that when you're looking for data, you're querying it correctly. Here's another example for Social Security numbers. When we do a Social Security number analysis, we then look at the Social Security numbers to validate that they're actually valid and that they're not scrambled. The table to the left is actually scrambled, and they actually used a fairly routine. They just put random digits in each one. And so for those of you on the call not familiar with the format and numbering of Social Security numbers, they're actually based on a certain pattern. So if you tell me your Social Security number, at least the first 5 digits, the first 3 digits are actually by state. So each state is assigned some of the first 3 digits. I'm from Michigan, so my actually first 3 digits are 379. And there's a table out there that you can look up and say, ask someone wherever they were born, and you can guess basically what their first 3 digits are. Then the next 2 digits are actually a time and day. So you can actually get down pretty close to the month that somebody was born by just knowing the first 5 digits. And you can figure out where they were born and actually almost when they were born. I think it's down to the month level. So what we do is actually do an analysis then of Social Security numbers to actually figure out if they're scrambled or not scrambled. And in this case, this company had major offices in the state of Washington area and the state of California. So as you can see, and historically about 40 to 50% of your employees will be born near the office that they're located in, especially for major states. So in this case, we saw a lot in California, but of course there's a lot of Social Security numbers assigned to California, so that's not bad. Then when we actually go down to the state of Washington, as you can see, there's 6,000 here, and Washington over here, there's only 300. So we were actually able to determine that this one table to the right was actually unscrambled Social Security numbers, and the one to the left was scrambled Social Security numbers. So those are kind of the analysis that you need to do to go through and figure out, okay, is my data scrambled? Isn't it scrambled? Are these actually valid Social Security numbers and things like that? So that's just kind of giving an overview of some of the things that we look at when we go through the analysis of finding sensitive data in the environment. And the problem is it's just scattered throughout the database. As you saw, there's 168 tables that had some form of Social Security numbers, bank account numbers, or credit card numbers in one e-business suite environment. And that's not uncommon. And very few of those are standard tables. So basically, the process to find sensitive data has to be somewhat rigorous, because you can't just say, oh yeah, we'll just do a query and find a couple columns. You need to actually go through and first figure out what you're defining as sensitive data. Most organizations have an enterprise level data privacy policy. So someone's documented out that yes, we protect sensitive data. Here's kind of, yeah, there's PII data, which is personally identifiable information, and we're going to protect that, and we're going to protect credit card numbers. But it's usually fairly high level, not very good for a DBA or a business analyst to take and say, okay, yeah, let's go protect this data. What's PII data? What's your definition? What's my definition? It can be very different. So you actually have to work with the organization and get that enterprise level policy down to a data protection policy level, and that's down to the data element level. So when I'm talking about data element level, I'm talking about bank account numbers. But you actually have to take it to the next step, because when I talk about bank account numbers, well, am I talking about customers, suppliers, the organizations? So when we actually get down to the data element level, we need to talk about bank account numbers. But when we talk about bank account numbers, there'll be actually 3 different versions. So it'll be customer bank account numbers, supplier bank account numbers, and the enterprise bank account numbers. What do I do for each of those elements? Who can see those data elements? When I talk about personally identifiable information, am I talking about name, address, date of birth, things like that? And then we also need to talk about what we have to do with that data. So what's the action? Do I need to encrypt it? Do I need to prevent access to it? Do I just need to audit it? Are general controls okay? Should I be scrambling in my data in my test and development environments? So that when we talk about data protection policy, you need to get to a very granular level for each data element to say what the data elements are, and then also what the action is, how do we need to protect it? And then from there, you can actually do the data discovery and some of the design work. So the data discovery may be just the DBA is running some scripts and trying to find the data, or actually purchasing a tool or using some of the scripts out on the internet to actually scan the database and try to find it. And then there's a lot of scripts also available that can actually look in operating system files. So you really have to do it both at an operating system level and a database level to find out where all the sensitive data is. The easiest ones to find are credit card numbers, social security numbers, and actually bank routing numbers. When we actually do a lot of our data discovery, we don't look for bank account numbers, we look for bank routing numbers, because bank account numbers vary dramatically in length. So you can have a bank account number as low as, I think, 6 and up to 25 digits. I think that's the range. And so it's very easy to find bank routing numbers because you know those are a predictable format. They're always 9 in length. They start with a 0, 2, or 3. So it's actually pretty easy to find those. So when you do your data discovery, it's important to tweak it a little bit, trying to make sure you find the right data. And then the output of the data discovery is really your detailed data inventory. So at that point, you're going by element and saying, okay, for this, bank account numbers for customers, they're stored in these 5 tables, and this is what we need to do for each of those tables. So that may be encryption, that may be adding additional controls on it, it may be auditing it, it may be scrambling and testing development, or it may be all of those. So if you've got credit card numbers, well, you have to encrypt those, and then also the PCI standard talks about auditing access to that and preventing access to that data. So once you've got your detailed data inventory, then you actually start talking about different solutions. And there's really 5 different solutions that are applicable to an Oracle E-Business Suite environment. If you're running credit cards, there's a native encryption. But that only works for credit card numbers. And I'll actually talk about each of these solutions in more detail. Then the second one is actually there's some add-on encryption products like Oracle TDE. If the encryption options don't work, then you can put in database access controls. So database access controls would be limiting access to only who needs to see that data. And really now, if those other items don't work, auditing is really the only solution. You're concerned about, is your DBA going in and querying all of these social security numbers and stealing them? A level of auditing can work there. And then the 5th area is actually scrambling. So when we clone our production environment down to test and development, we gain some of the benefits from the previous protections we put in production because all the database access controls are most likely copied down to the test and development environments. The encryption's copied down. But then in our test and development environments, we're probably needing to scramble data. And so even in production, we may not provide much access control around salary information because we know production's locked down, DBAs have access to it. That's about it. We know the HR users have it through the application, but really not much ad hoc access. Well, in test and development, you might open up test and development to all your developers, especially offshore developers, and you really need to be scrambling all that data. And the number of data elements that you're scrambling typically far exceeds those that you're attempting to encrypt or actually protect rigorously in production. And then the final area that some people miss is really adding an entire layer of security and hardening to the environment. Well, you need to harden the entire environment. You need to have good general IT controls. One case where we were talking to a customer about implementing encryption and things like that, and we had to point out, oh, by the way, your app's password, the default password is apps. You really need to change that because no matter what we do, unless you change that app's password, somebody can get in pretty easily and steal all the data no matter what we do. So you can't forget about the general security and hardening, applying Oracle Critical Patch updates on a regular basis, changing passwords, scanning the environment to make sure nothing has been opened up like default passwords. We always see the CTX sys database account get its password reset. That's a very common problem that we see. Unless you're checking for those things on a periodic basis, you're opening up holes, and basically every protection you try to put in place is just going to be circumvented pretty easily with things like that. So that's kind of the process at a high level and kind of the high level solutions. And we'll kind of break this down now, some of those solutions, and talk about each one in a little bit more depth. So basically then the next step is after the process is when we start talking about solutions, what are we trying to protect against? What are the ways that people can access the data in the environment? What are the threats? And then what are our options? So this is actually the option matrix that we came up with for one customer. So they were very concerned. They were looking to implement some different solutions. And we actually then mapped those out to what are some of the common threats. So who can access the data and what are some of the threats that could also happen. So when we're talking about different ways that people can access the data, well, people can access it through the front end. So you've got your end users accessing it. Hopefully the application controls are there. But then we've got application administrators. People are using sysadmin. Some of the application controls don't fit in there, so how do we protect against that? In the back end of the database, we've got both DBAs accessing it, application DBAs. And we differentiate DBAs and application DBAs as what passwords they have. You may have a DBA who only is responsible for doing backups, but he may not have the app's password. That's actually an important distinction because some of the products like Oracle Database Vault, once you have the app's password, Database Vault provides you very little protection. So if your environment is segregated fairly well, if you've got maybe 20 DBAs, and some DBAs are responsible for backups and some are responsible for the application, you have one different problem than if you just have 2 DBAs who have full access to the system. And then you've got other database accounts. You may have an apps read account. You may have ad hoc users accessing the database, so you need to provide protection at that. Then you have to start thinking about it at the operating system level. So the Unix admins can steal the database files and then mount those offline. You've got backup tapes going everywhere. So what happens with your backup tapes? You may be doing backups online or offline. So what's happening with the backup tape? Is the data encrypted on that? If it falls off the back of the truck, which you actually hear about quite often, somebody lost a backup tape with all their HR data, what's happened to that backup tape? Can somebody access it, mount the tape, get the data off? How about on the USB key? So if someone's backed up a database file, the USB key for some reason, is that encrypted? Then you've got actually exploitation and security vulnerabilities at different levels. What happens if you're not applying Oracle critical patch updates to both the application and the database? You're not applying operating system security patches. So how does that impact the environment? Can people go in through your iSupplier and actually steal all your credit card numbers? Well, if you're running iSupplier on the internet, they have full access to the apps accounts, so if they can find a vulnerability in the application, they can actually steal all your HR data. So you need to think about all these different threats, different ways that people access the data. What happens is a lot of people just get concerned about the DBAs. Well, I'm concerned about the DBAs stealing data, but I don't worry about anything else. Well, that's probably the least of your concern. You have to worry about everything. The DBAs, as long as they're named set, at least you have some control over that. You don't have control over iSupplier that 1 billion people can access your iSupplier by just doing a Google search and pulling it up. So these are all the things you need to be thinking about when you're talking about how to protect the data. So that's kind of the matrix. Once you've kind of decided on some of the solutions, is how do you determine which ones are the best for your environment? And this is typically a layered approach. Not one solution works for everything. So now we'll talk about some of the solutions in a little bit more detail. So first, encryption. There's a couple different forms of encryption that you need to be thinking about. And they provide different levels of protection. They work differently, and not a single level of encryption will work in Oracle Business Suite to do everything. So the first is storage. This is disk level encryption, so data at rest. So basically when I'm writing data out, it's getting stored on the disk. Then there's access or data in use. So this is basically more like an application or database level encryption. So things are actually encrypted in the database, so unless I have specific access, I can't get to that data, even if I'm in the application or the database. And then finally, there's network encryption, so that's data in motion. So that's basically when I'm sending Social Security numbers across the internet or across my internal network, is that encrypted? And you really have two types there. You have it between the client, that's your end users, and the application server, and then you have from the application server to the database. Or if people are accessing the database directly, that's using SQLnet. And so you've got two different encryption solutions there, SSL, SQLnet encryption. We see most people really encrypting from the end user perspective, but very seldom does anyone ever do SQLnet encryption. So you do have an issue that you may have Social Security numbers or credit card numbers across your internal network if people are doing ad hoc queries against the database. We won't talk about network encryption anymore and focus more on data at rest and data in use for the rest of the presentation. But SQLnet encryption is definitely an option for people who are very concerned about database access, and everyone really should be using SSL when they're accessing Oracle Business Suite, even internally. So if you go to your Oracle Business Suite and you look at the URL in your browser, it really should say HTTPS, not just HTTP. And that would basically mean if you're actually seeing data encrypted or unencrypted. So some of the encryption solutions are at different layers. So when we talk about the different layers, is really who can access it and what level of access control it is. So when we talk about application level encryption, typically I'm setting my access layer at the responsibility. So I'm determining if someone has a certain responsibility, if they can see the data encrypted or unencrypted. application level encryption is actually the best. If you want to do anything, you want to have application level encryption. So this is basically every time the application is reading or writing data, it's basically encrypting it. And Oracle has a solution for eBusiness Suite for credit card numbers only at the application level. So Oracle provides a very robust out-of-the-box capability. For your customizations, Oracle actually has a whole toolkit, DBMS Crypto. You can also use the standard Oracle eBusiness Suite encryption, FND Vault, to also do encryption. But that's for customizations. You probably would never be using that to encrypt the standard table, like PR, all people F for Social Security numbers. There are a number of database encryption solutions. These would basically be limiting access to certain data to see it encrypted or unencrypted based on database account. You can do roles and things like that. So this would allow the apps account to see all the data, but anybody else would see Social Security numbers, credit card numbers encrypted and couldn't decrypt them. Well, unfortunately, all the solutions in the market, most of them work on views and triggers, and there's a couple other ways they work. None of the solutions out there really support Oracle eBusiness Suite. And the problem is that the Oracle eBusiness Suite is a very complicated data model. There's lots of views already there. Typically, if you're doing a query, you're already going through a view and a view. So we've seen customers try to implement some of the solutions out there. Companies like Protegrity, SafeNet, and these solutions don't work well with the eBusiness Suite, so I wouldn't even recommend looking at them. And finally, the last level of encryption is at the disk or storage level. So this is basically at the database level access. So that once you're in the database, every user, if they have access within the database, sees the data unencrypted. So it's really providing you some capabilities if you lose a disk drive, if you lose a backup tape. And this is where Oracle's transparent data encryption, TDE, falls in. There's a number of other third-party solutions like Metric. Most of the disk vendors also have an encryption solution, so once the data is written out. And the only real difference between these different products is actually when they encrypt it. So in the Oracle's, it's encrypted within the read and write when you're reading and writing database blocks. The other solutions at the disk level are actually when you're writing it physically to disk and things like that. There's really not much of a difference between them. Oracle Transparent Data Encryption provides a few other capabilities, and we'll talk about that in a second. So there's a number of different encryption options, but again, these aren't all inclusive. So when we're talking about disk and storage, once you're in the database, you don't see much of a benefit. Application level is only providing credit cards. So anyone who's now thinking, well, we're just going to encrypt everything, there's not a great solution for Oracle eBusiness Suite. So we'll talk about the Oracle native eBusiness Suite credit card encryption first. And so this is a standard functionality by Oracle. It's at the application level. So basically what Oracle did was every time there's a credit card number in the database, they read and write it encrypted. So they actually had to change all the code. And in 11i, we kind of did an analysis of the patch, and there were 64 different packages, a number of web pages, and 18 different forms that Oracle had to modify to actually make credit card encryption work. So that's the key here, is Oracle had to modify the application pretty significantly to make this work. It's a very good solution, but a lot of people ask, oh, when are they going to do Social Security numbers? Well, Social Security numbers are used significantly more than credit card numbers in the environment, and this is how much effort it took them just to do credit card numbers. So we don't really anticipate Oracle releasing a Social Security number encryption patch anytime soon. You can do some of it in Fusion. I'm not sure the capabilities there, but that was an application written from scratch, so you got a lot more capabilities. One caveat about the application level encryption is it's not enabled by default. So this is a pure standard by PCI. So if you've got credit card numbers in your eBusiness Suite environment, you have to encrypt them. But Oracle gives you the capability, but of course doesn't enable it by default. So here's the MetaLink notes, so the My Oracle support notes that you can actually get on how to enable it. So what does the patch do? Well, the patch goes through all the tables that used to have credit card numbers, which are all in pink here. And so Oracle had just scattered credit card numbers about based on module development. So when order management needed credit card numbers, they basically stored in their own table. When service contracts needed credit card numbers, they stored in their own table. what the credit card patch does is actually consolidates all that data, and you actually run concurrent manager programs, and it physically moves the credit card numbers and encrypts them at the same time from those other tables into IDY security segments. And then when you apply the patch and enable it, it then changes the way all those modules work to actually read and write credit card numbers, so it knows to go to the IDY security segments instead of going to the native table. So it's a pretty invasive patch, but it works exceptionally well. So if you've got credit card numbers in your eBusiness Suite environment, you need to be running this patch and enable it. So if you need to do encryption, you can't do, and it's more than just credit card numbers, including now, so security numbers, bank account numbers, other data. One of the key solutions that most people implement is Oracle Transparent Data Encryption. So this is an add-on from Oracle, so it's a fairly expensive option, priced by CPU, so you do have to be careful of the cost and really look at it. And one advantage of TD is there's no change to anything. It's basically very transparent. You enable it, tell it what columns or table spaces to do, and it works fairly well. There are a few limitations about what you can actually encrypt. Based on Oracle eBusiness Suite environments, we very seldom ever see a customer have a problem. Occasionally a custom column, but all the standard Oracle eBusiness Suite columns can be encrypted that typically have sensitive data like credit card numbers, social security numbers, bank account numbers, date of birth, things like that. Those are actually fairly easy to do. Unfortunately, when you remember, Oracle TD is a disk encryption solution, so it's only data at rest. So it's protecting you if you lose a disk drive, a database file, a backup file. But once you're an authenticated user and you have rights to see that information in the database, you basically have full access to it. So if you encrypt national identifier in P or all people F, and you enable TD, if I go in as the apps account, I can fully see it. If I have a custom database account that has access to that table, I can fully see it. The only time it's encrypted is actually when it's on disk. And so if I get a Unix administrator who goes in and steals my database files, it's protected. But once somebody's into the database, it's not protected. I would probably ask your legal department if this satisfies the requirement, because in a number of the breach notification laws, they specifically have exceptions for if the data was encrypted, you do not need to notify people in case of a breach. Well, the data is encrypted, but what happens if someone just, my DBA went in and stole all the data by having an authenticated session? Well, at that point, the data wasn't encrypted. It might have been encrypted on tape, but it was not encrypted when the person stole the data. So TD may meet some of the legal requirements. My opinion probably doesn't, because if you lose the data, if you lose a backup tape, yes, probably don't have to notify anyone, but if someone goes and actually steals the data from the database, I don't think you're covered at that point. So TD does cover, there's actually was a theft in Chicago a couple of years ago that basically some guys took a power saw and cut the concrete wall, big hole in the concrete wall of the data center, went in, basically tasered the night manager and stole 20 data servers. So basically you're covered in that case if someone does that. If you lose a backup tape, you're covered, but you're not covered if someone logs into the database. So TD has a good solution. It fits in for a lot of different customers who say, well, at least we need something. We need some level of encryption. So it's actually a fairly good solution for that. But you just have to understand the caveats. It doesn't do everything. Starting with 11G, Oracle added another option. So you can actually do two things, and I'll assume you're on 11G. You can do column level encryption or table space level encryption. So if you do column level encryption, you can say national identifier in the P or all people F table is what I need to encrypt. We recommend using column level encryption for standard eBusiness Suite tables. It works well. You don't get a lot of performance problems. You're not encrypting all the other transactional data. So you can pick off columns, and probably if you did 20 columns, TD works well. A lot of people are running it. You get a little bit of a performance overhead. CPU-wise is what is mostly hit, because that's what encryption is. It just takes a little bit of CPU effort. So you might see a 5% CPU utilization on your database server for heavy type of queries and things like that. Oracle also provides table space encryption. So this is basically now encrypting all the tables in that one table space. Based on the table space design of 11i and R12, it becomes a little bit more difficult to do entire table space encryption because they tend to be fairly large. Where table space encryption works really well is for your custom tables. So you put all your custom tables into a custom table space, and then you can use table space encryption. And why would you want to encrypt all your custom tables? There's one easy answer to that, is that I don't know where all my sensitive data is, and I don't trust my change control process to inform me when somebody added a credit card number or a social security number to a new interface, which therefore now I have a new table, which now I have to start encrypting. Well, if I do table space encryption from all my custom tables, and I may also have it divided up by HR maybe in one table space and AP maybe in another. Well, I want to encrypt all my HR data, especially my custom tables, because I don't know where social security numbers might be. I don't know where salary information might be. So table space encryption actually works fairly well. And those tend not to be high transactional volume tables either. So I won't get much of a performance overhead as I will if I tried to do let's say the HR schema, and I had to move those tables into a separate table space, and those are pretty active tables. I'd probably see a little bit more performance overhead if I was encrypting all that data. Oracle's pretty efficient though. Even with table space encryption, you don't get a huge overhead, but this is a little bit better design. It kind of guarantees a little bit more probability of success. So column level encryption for standard tables, table space encryption for custom tables. A little bit of performance overhead, so 5 to 20%. It just depends. This is you got to try it to see if it works type thing. So that was kind of the different encryption options for eBusiness Suite. So now let's talk about controlling access real quick. So there's a couple different solutions here, and you want to really think about defense in depth. There's no one good solution. This now is talking about controlling access that if I can't go through and encrypt certain columns for some reason, TD isn't providing me enough of a solution, Oracle eBusiness Suite only provides credit card encryption, and I want to provide more protection on social security numbers, now I have a number of layers of database access controls, application access controls. These are more different layers, so I actually can probably implement multiple of these at a time. So first thing, I'll rely on the application security. So I at least have to make sure my roles and responsibilities, menus, and functions work well, so I'm not giving a low-level clerk full access to all the HR data to see every social security number. Another option is actually doing eBusiness Suite personalizations. So we had one client we worked with that said basically no one in HR could see social security numbers except for a few people, and unfortunately the Oracle eBusiness Suite HR design wasn't sufficient enough, so they actually put personalizations on just about every time social security number appeared by responsibility to limit access to who could actually see social security numbers within HR. There is a couple third-party packages. One company, Mentis, actually makes data masking products, so you can actually mask different display of different data within the application in the database. At the database level, you need to get your database access controls, your roles and privileges well defined. There's a solution fine-grained access controls, which is actually included with the database that provide additional capabilities. Then if you need to take this another step farther, Oracle has the add-on product database vault. So those are at the application and database level. And then you need to think a little bit about operating system security. Are you going to eliminate access by Unix administrators, other people who might have operating system level access? There's tools like PowerBroker and Sudo that can actually help you with that. So in terms of access to sensitive data, the first thing you really need to do, and our #1 security recommendation no matter what, if there's one thing you're going to do with your Oracle eBusiness Suite environment to help protect it, is eliminate as much direct access to the database as possible. By eliminating direct access, you eliminate the capability of people exploiting things via Oracle critical patch updates you may not have applied, just ad hoc access. There's a number of different ways you can do that using the managed SQLnet access within the Oracle eBusiness Suite. What's happening there is you're basically specifying IP addresses who can connect to the database. That doesn't typically work very well because most people don't have their environment that well controlled. The best option is basically putting a firewall in front of the data center or in front of your database server to eliminate access except for people you approve. And then you either use VPNs or jump servers. And a jump server is like a Citrix box that basically I have to log into, and that will allow me then to be able to query the database and things like that. To get rid of your apps read account. I can't tell you how many times we find just a generic apps read account. You really should have named database accounts for each user with very specific privileges. The problem about doing some of the specific privileges is there's not a granularity of database privileges to say, well, I want to just eliminate access to PRL people F. I want access to everything else except for PRL people F table, which has Social Security numbers. Well, in the Oracle model, you can't do that. So it gets very difficult to limit access to just a few tables and give access to everything else. Plus, in the Oracle database model, you need access to like PRL people F because that's all your people. So unless you then create another view on top of that and do things like that, it becomes a little bit more difficult. Well, one solution around that problem is you can grant access to every single table, and then you can use something like fine-grained access control to actually give you very granular level access to a specific column or not a column. So fine-grained access control comes with the database, and we've actually implemented this for a number of clients. So you actually create policies, and you can actually block a specific column. The classic one here is PRL people F. That's the table that has your Social Security numbers. It's a list of all your employees in HR. Well, you don't want national identifier to everybody, but they need to see the least list of employees. So you can actually create a fine-grained access control policy that if someone tries to access that table, they can access the table, but when they see national identifier, it'll actually be returned with all nulls. So they won't be able to see that one column in that one table. And it works fairly well. If you need a little bit more control in the environment, Oracle Database Vault works really well. Oracle Database Vault is a very powerful tool, and it can provide you pretty good access control. And you can do things like IP address and by time. So if you know your batch server only accesses the database during batch hours after 5 p.m. until maybe 6 a.m., you can actually use Database Vault to do that. You can also segregate the DBAs and what they do. It's a fairly expensive licensed option, but there's a couple scenarios where it works really well. If you have a lot of different DBAs and they have different roles, so you might have one DBA who's just responsible for, let's say, creating new database accounts or going in and doing backups and things like that. You can actually segregate those DBAs by using Database Vault. Once somebody has access to the system, apps, or CTX-SYS, and a couple of other schema accounts in Oracle Business Suite, Database Vault doesn't work. You have to turn off Database Vault to apply certain Oracle Business Suite patches, things like that. But it works if you do have a large DBA team you need to provide some segregation. The place it really works, and we've seen it very successfully implemented, is if you have some sort of database consolidation. So you might be running an Oracle Business Suite database, but you've got multiple applications in that single database. You might have an e-commerce application coming in and using it. And in this case, you might have DBAs who have to access those other applications, maintain those other applications, but they can't have access to the Business Suite environment. Database Vault works very well in that situation, where those people typically wouldn't have the SYS or system account, but they would have full DBA privileges over those certain applications. Database Vault is an excellent solution for that scenario. We've seen it very successfully implemented. Otherwise, Database Vault's not implemented by many people, except maybe for the IP controls. So it's a good solution if you need it. I wouldn't recommend it just wholeheartedly for everybody. Very few people, I think, would do benefit from it, even though I see a lot of people, companies buying it and then trying to implement it and actually not doing much with it. So finally, if we talk about encryption and data access controls, well, maybe those aren't working. So now you're kind of falling back to auditing. So if you can't do the other ones, you now have to actually audit access to those tables that you think have sensitive data, because for some reason you can't encrypt them, you can't prevent full access to it, maybe on the DBAs. So maybe as part of your data protection policy, says, well, I care about even DBAs. I can't have DBAs querying all the credit card numbers or the Social Security numbers. I can't prevent them because I can't put in enough layers of access control around the DBAs because they still always have the apps account, they have the SYS account, they have the system account. So I need to audit full access to that. And there's really two solutions to auditing. Is either using the native audit trail, and really if you're going to use the native audit trail, we highly recommend that you actually use syslog auditing. Syslog is actually the logging system that Unix uses. And you can actually set it up so the Oracle audit trail, instead of being stored in the database where it can be manipulated by the DBAs, deleted, they can do whatever they want, or if a hacker gets in, most likely they're going to be able to hack in and get DBA privileges and then they'd be able to manipulate the audit trail. So the best way to protect it is actually when you enable the native audit trail, you actually enable syslog auditing. And what happens is the Oracle native audit trail gets written out immediately to syslog, and then you can actually have it written to either a secure location, so the DBAs, unless they have root access on the Unix server, can't access it, or you can take it to the next step and actually have it immediately sent from the server into an external logging environment. So anyone familiar or any companies running tools like ArcSight, RSA, Envision, Splunk, those are examples of logging tools that now you can actually take the native audit trail and actually immediately have it sent to those tools where it's protected, it can be reported on, it can be alerted on. Native auditing has some limitations. It can have a performance overhead, so there is actually a number of third-party auditing solutions also available, tools like Imperva, Guardium. These actually provide very robust, and they're external, and they typically run as an appliance, and they have zero performance overhead, and they can't be manipulated by the DBAs at all, because the DBAs can still turn off the native audit trail. So if you do need to have a very robust level of auditing, protecting, and seeing what the DBAs are doing, an external auditing solution like an Imperva or Guardium is really the only way you can go. Unfortunately, those are fairly difficult to implement, fairly expensive, but if you need that level of protection, that's really the way you have to go. So that's basically kind of looking at auditing at a high level. So if you can't do the others, then you audit. Then finally, we're going to talk about quickly data masking and data scrambling. And I always call it data scrambling because to me, data masking can either work on the front end of the application in production or can work in test and development. Data scrambling is very specific that when I'm referring to scrambling, I mean taking the data from production, and when I'm doing my clone to test and development, I'm taking things like credit card numbers and social security numbers and basically totally changing them so that you can never get back to the original value. So in your test and development environment, you should be scrambling on many, many different columns. And that can go anywhere from just credit card numbers to social security numbers to also very detailed information on all the PII data, all the salary information, things like that, bank account numbers. All that data typically should be scrambled in your test and development environments. You should also be checking periodically that you've actually gotten all the data elements you need to scramble. We see that quite often that, yeah, the company's got maybe 80 items on their scrambling list, then when you do the search, you find another 20 columns that actually have sensitive data. Another thing that you should also be thinking about when you're actually doing scrambling is also purging data. PCI is very specific on how much credit card data you're allowed to keep in your environment. They recommend 1 to 2 years, kind of on average about 18 months. Well, it's very difficult to purge data out of Oracle Business Suite. If you've got 5 years of credit card data, that's just way too much to even have in production, let alone now copying it down to test and development. So for data scrambling solutions, there's a couple of different ways you can do it. You can write custom scripts, and so if you have a small number of elements, that's typically the best way to go. If you've got maybe 10, 20 different elements, credit card numbers, social security numbers, usually custom scripts are the best way. Oracle does have 2 products. In R12 and kind of in the most recent versions, really you should be running the Oracle Enterprise Manager Data Masking Pack. But again, this is an add-on. But Oracle Applications team has released an EBS template pack that will go on Data Masking Pack for all the standard tables. You still have to spend a lot of work on setting up within the data masking products all your custom tables. And then the Application Manager pack also has a data masking, so that works during cloning. The data masking pack as part of OEM is much more sophisticated than the app data masking. But it's really, if you want to use a tool like that, look at both products, see which one that will work for you. There's also a third-party product from Mentis called iScramble that works very well with Oracle Business Suite because it's got the rules defined. It's got a lot of pre-built data for Oracle Business Suite. And that's really where a lot of the effort is, trying to figure out the rules. Once you've figured out what you need to scramble, unless you need to maintain lots of referential integrity, and most Oracle Business Suite tables you don't. There are some cases where you find you'll have to. It's actually pretty easy just to write your own scripts, especially if you're doing social security numbers and things like that. If you really need to scramble many, many columns, then you need to buy a product. For data scrambling, there's a couple of best practices to look at. One is keep it simple. When you're doing scrambling, if you've got a large amount of data, it's not uncommon to get up into 8, 9, 10, 12-hour run times for your data scrambling. If you've got a couple million credit card numbers, 400,000 or 500,000 employee records, the scrambling can take hours and hours and hours. And then sometimes you get data issues because there is no referential integrity in the database. It's all at the application level, so scrambling can become very complicated if you're doing many data elements. Another thing we recommend is using some predictable data patterns. One of the things we like to do for Social Security numbers is always prefix your scrambled data with a 7. Social Security numbers that start with a 7 typically were for railroad employees, so they're valid Social Security numbers. They've changed recently in the last year or two. They've actually changed to using random Social Security numbers. So they used to be assigned by state, that now any Social Security number is valid. But if you use a predictable pattern for all your scrambled data, like putting a 7 in front of it, it acts as an ad hoc control. So anybody in a test or development environment starts seeing all kind of Social Security numbers that don't start with a 7. Well, typically what happens is somebody does a test data, they load in some test data that's unscrambled in a test and development environment. And if you do things like predictable patterns, like starting Social Security numbers with a 7, putting 1s in the center of credit card numbers and things like that, everybody in the organization knows that whenever they see that data in test and development, they know it's valid test data versus real data. If they see real data, they're very quick to act versus just using purely random data, because then no one knows if it's good or bad data. So that's kind of data scrambling at a high level. Most organizations are starting to do it. The problem is that we see is they're just not getting all the columns. It's very difficult to find every single column unless you're using a tool to actually search for the data. So kind of to wrap it up, we'll open up to questions next. So now we're talking about the different data protection options. And so this was an example of here's the threats, here's the way people can access the data, and then all the different options and solutions I just talked about. Here's kind of how it maps out, what's actually controlled, what's encrypted, where each option works. As you can see, there's some holes. When we look at option 3, Oracle TD, well, I'm not getting much protection in terms of encryption, except for operating system and offline access to backup files. I'm not getting much other benefit out of it. So you kind of have to come up with several different solutions. And as you can see, this customer actually took the last columns because they were looking at doing some level of encryption, but they actually had to add in some database access controls and also auditing to make everything work correctly. So it's not an easy, this isn't just go slam something in, there's a silver bullet out there. This is basically you need to do some work and analysis, and typically doing a full data protection project is its own project, and it will take somebody a couple weeks of effort to actually go through these different options, get them implemented, and things like that. So that's data protection at a high level. We've kind of talked about a bunch of different solutions, and we can now open up to some questions.
Thanks, Steve. Let's see here. First question. If we're not applying the Oracle critical patch updates, does encryption help us against SQL injection attacks?
Actually, a very good question, because if you start looking through some of the different protection options, so if, let's say we've got credit card numbers and we're most concerned about credit card numbers, and we use the native Oracle E-Business Suite encryption. Well, it provides you some benefit, but actually if we look right here under line 8, under EBS encryption, well, we have an E-. So the minus means, well, it's kind of encrypted, but it's not covered by everything. So if I actually have a SQL injection bug in iSupplier, somebody can fully query any data in the database because that's always running as apps. So yes, it provides some protection against certain issues, but not against all of them. So if I've got a SQL injection bug in iSupplier and I'm on the internet, people can basically query just about any data because that's going as apps, and apps always need full unencrypted access to the data. So this is, again, why you need defense in depth. You need a web application firewall or something to hopefully block SQL injection attacks. You want to apply the latest critical patch updates and things like that. So none of these solutions are complete, and you need to think about a layered defense in depth strategy.
All right, second question. Kind of interesting. Is it better to stay with the Oracle solution, which costs a fortune, look at third-party products?
This really gets down to what you're trying to do at the end of the day, how well you want the product supported. The Oracle solutions work fairly well for limited circumstances. I don't think Oracle TD for the cost is a great benefit, but a lot of people do implement it. Database Vault provides is really the only solution in certain circumstances, but again, you have to turn it off when you're applying certain patches. Some of the third-party products actually work fairly well and are a lot cheaper. So I'd definitely look at both Oracle and third-party products to solve this problem and figure out which one, based on your requirements, meets it the best.
Next question. We currently mask sensitive data when cloning our production instance to test and development instances. Just this month, we updated to Oracle EBS R12. So are you better than those silver bullet promisers?
Okay. Interesting question. So first thing is there's really no good silver bullet. As we kind of went through this presentation, the reason we do this is a lot of people say, yeah, just implement our product and you're fully covered. As you can see, there's no one good answer. And Integrity doesn't provide a product in this area. What we do is provide consulting services and security design services to help you walk through this process, help you find the sensitive data, to find out your data privacy policy, then figure out which of these solutions is actually best for you and which set of solutions is best. Typically, I've never seen a customer say, oh yeah, we just bought that product off the shelf and implemented it and actually covered everything on this chart here, all the different threats. You need to be looking at this. You need to be hardening the entire environment. So it's a whole process to do this. And actually, that's what Integrity provides versus a silver bullet. There is no silver bullet. You need to do a process. You need to walk through each step and make sure it's done right and well.
All right, we have one more, which is pretty specific to the credit card numbers. It says, regarding encrypting credit card numbers, I applied the encryption patch to the applications to see from an order or receivables form the credit card is encrypted. And in this actual OE underscore order underscore headers underscore all table, I see the unencrypted credit card number. Did I miss something? Is something supposed to be encrypted? And by the way, this person is running on 11.5.10.2.
We've seen that problem before, is when people aren't using the interface tables and actually doing direct writes to the order management tables. I have not seen that problem if you're using the standard either interface tables or through kind of the forms and web pages to actually enter an order. If you're kind of following through one credit card number and you've implemented the patch correctly, gone through all the steps in the MetaLink notes, it should work. We haven't seen it not work, but now to say, remember, Oracle had to rewrite all the code to actually encrypt it and decrypt it. What we have seen quite often is when you do run the concurrent manager programs, it moves the data from the order headers all table into the IBOI security segments table. We've seen that actually not move all the data. So you'll get like maybe 70 or 80% of the data moved, but there's actually, and we saw this in one case where I think they had about 4 or 5 million credit card numbers in that table. It moved like 3 million, but there was like still 1 million credit card numbers in that table. And that was a big problem. We had to actually go out and purge. And it typically it was a little bit older data. It moved all the recent data, but the older data didn't move. So it's not perfect. We've seen it actually do different things over time. Or it actually finds invalid credit card numbers. We've seen that. Actually, if a transaction was rejected because maybe the expiration date was wrong, it didn't move those records. So definitely after you enable the credit card encryption patch, go through those tables very carefully and actually look that every single column or every single order's credit card number is encrypted and actually has the identifier there versus actually having an actual credit card number.